compared to normal one. That is damage of muscle. Suppose this is athlete and after heavy exercise there is some degree of muscle destruction or damage, definitely, but that is physiological damage, because we have two types of abnormalities in our body. One is physiological and another is pathological. Physiological, that means that it will heal very soon automatically, and that is due to something our desire. Suppose we love to play and definitely we have some degree of muscle damage. That is physiological. But pathological, that means suppose you get accident or you have some disease or get some trauma or something like that is pathological condition. So we will discuss about more in pathological conditions rather than physiological. Yes, muscle damage may occur following physiological and or pathological condition. I already told you that. Blood analysis and urine analysis provide a composite picture of muscle status and better estimation of muscle stress. See, here I am saying blood and urine, but these are not limited actually. We should say blood fluids or body fluids generally. Any fluid that is in body, that is body fluid, blood, urine, cerebrospinal fluid, and synovial fluids, many pericardial fluids, many peritoneal fluids, many fluids are there, and we can analyze them. For chemical substances, we can measure them in biochemistry. For cytological things or cellular structure, we refer to pathology or histopathology. For to isolate some microorganism like in meningitis, we particularly look for either it's viral meningitis or bacterial meningitis. That time we do culture in microbiology laboratory. But we are going for the biochemical part only today. And yes, muscle damage may occur following physiological or pathological condition. And blood and other body fluids, when they measure for some biochemical substances, it reflects very ideal status about muscle damage. Yes, biochemical marker of muscle damage. There are many biochemical markers, but we are going to talk about very common biomarkers, very common. There are many markers nowadays, and every day or every year there are huge number of research going on these to develop new and more potential markers globally. But we are just talking about those markers which are already established in the market and easily available in our context. A biological molecule found in blood or other fluids or tissue that indicates a normal or abnormal process such as disease or condition. These are marker actually. A biochemical marker is measured to diagnose and follow up disease or treatment. Sometimes we ask, especially why we need to measure these biochemical markers. The answer is very simple. Yes, we to know how serious is disease, how serious our muscle is, or to take the after follow-up. Suppose you get very high amount of particular protein or enzyme 1 week ago, but now you want to check whether it's going better or it's more worse. You need to identify through these biochemical markers. That means to diagnose or follow up the treatment, and to confirm the disease, we measure these biochemical markers. And serum level of skeletal muscle enzyme or proteins are biomarkers of the functional status of muscle tissue, and very widely in both pathological and physiological conditions. That means generally we measure many things in serum, and mostly they are enzymes and protein in nature, but it's not limited. Many times we use CSF as a fluid. Even we can use urine to see the kidney status, and other fluids as well, but serum is the most common one to identify the status of muscle tissue damage, and in both physiological as well as pathological conditions. Enzymes as a diagnostic marker. Yes, the major focus is in enzyme because most of the enzymes are protein, and yes, we are talking about the enzymes today more. Tissue damage or necrosis resulting from injury or disease is generally accompanied by increase in the level of several non-functional plasma enzymes. That means See, we have a number of cells, and inside cell there is a huge number of huge amount of enzyme. Once they damage either physiologically or pathologically, the number of more cell damage, the quantity of enzyme more released into the blood, and we are measuring that amount of enzyme in our blood. And if it is high, that means it indirectly indicating that there is something wrong in our tissue or cell level. Increased plasma level of intracellular enzyme due to cell damage. See, these image, these yellow part inside the cell, these are supposed to consider enzyme. Once these cell damage, they come into the blood, and that enzyme we are measuring in our clinical laboratory. This is how simply it uh, possible to measure, or the process of how it happen in our body. And possible mechanism responsible increase the serum levels of these markers or enzyme. What are the reason? One, the most big picture I just said, due to the damage of cell, and that enzyme is inside the cell, and that once cell damage, that enzyme comes into the blood, and that blood we test in our laboratory. See, there are some other reasons. Increased release due to cell damage or necrosis, increase the permeability cell without gross cellular damage. Sometimes there is a cell is not particularly damaged, but this permeability is increased due to some hormonal abnormalities. That time also there is a chances of that enzyme high in our blood. Increase the production of enzyme within cell, resulting in increased in serum by overflow. Another reason, maybe the enzymes are synthesized in high amount. Even cells are not being damaged, the permeability is normal, but the production is very high due to some hormones, because for the regulation of the enzymes, ultimately hormones are the responsible, and when there is a high amount of hormone or low amount of hormone, there is a chances of changes in the enzyme level. Increase in tissue source of enzyme is malignancy. Yes, this is one very abnormal condition. That means suppose a person having tumor or malignant tumor or carcinoma, that time there is, we know that carcinoma or malignancy, these are abnormal proliferation of cells. That means proliferation of abnormal cells. That means suppose we have generally there are 1,000 cells. Now due to malignancy there are million cells. That means the amount of certain enzymes or protein definitely high, because the cells number is very high in malignancy. And these are the increased release. And sometimes impaired deposition is another reason. That means the production is normal, but deposition or accumulation is high. Increased level of obstructive jaundice. Suppose there is obstruction in our gallbladder due to cholelithiasis. That time there is a chances of accumulation of these bilirubin, and if we measure bilirubin we high, that means there is obstructive jaundice, and that time that bilirubin is a marker of jaundice. Increased level of renal failure. Increased level of renal failures. Sometimes, last time I said, urea is very high when there is a kidney failure. That means that is deposition, abnormal deposition, because kidney has to filtrate that urea every day in a sufficient amount, but due to renal failure there is accumulation of urea in the blood, and that urea is very high. That is why we can say there is something wrong in your kidney if we found very high amount of creatinine or urea. That is why happening, because of impaired deposition or abnormal accumulation of these waste product in our body. And not only increase, sometimes we measure decrease also. Suppose decreased formation, which may either genetic or acquired, or enzyme inhibition, or lack of cofactors or coenzymes. Like many times we found something high in our blood in particular disease, but there are some disease which has a very low these biochemical markers that indicate there is something wrong, and that happens due to decreased formation, which may either genetic by birth, acquired after birth, or something wrong happened with, and either due to enzymic inhibition or lack of cofactor or coenzymes. These are the possible reasons we may get abnormal value of our biochemical markers. It may be high, it may be low. Mostly we are getting high, but it doesn't mean that always we get high. There are many things we get low. Suppose there is a liver disease, and if we measure protein or albumin, there is low albumin protein because liver is not working properly and the proteins are synthesized in liver. That means that time we have to see for the lower value. Yes, this is a reason. What are the possible reasons for the behind of these biochemical markers be high or low? This is the answer. And next, now, clinical significance of enzyme estimation. What are the clinical pictures? What is the clinical significance of these enzymes estimation or measurement of these enzymes? Single or serial assay of serum activity is selected as an enzyme, and that means we may measure once only, or we may measure serially. Today we will measure, tomorrow we will measure, day after tomorrow we will measure. Yes, because we need to see how much change is occurring in particularly in specific time duration. Suppose after 24 hours or 48 hours, how much change is produced in the particular time period. It helps in the making the diagnosis, different diagnosis, early detection of disease. See, decades or a couple of decades ago, just lab are considered as they are just for the diagnosis. Nowadays, not diagnosis only, for prevention also these laboratories are being used in global setting. And to diagnosis, to differential diagnosis. That means suppose you don't know a person coming from this pandemic area, and you are just looking that symptoms are very, very similar to this coronavirus. But how do you differentiate it's corona or common flu, or how you know it's common cold or it's corona? It's very difficult to. That time we need some differential diagnosis. That means we need to do corona test in our saliva or nasal secretion. These are the body fluids again. That means we not only diagnosis, we help in the differential diagnosis as well. Help in the certain progress of disease. We also check how progress is there. Suppose you have seen that once positive, they are kept in isolation, and after a few days, they again test for the same. And if they are still positive, they are still kept in isolation. And again, they do the same test. And if the negative, that means we see that prognosis is very good and the patient can be discharged. Help in the sending progesterone drug in the disease. Sometimes, suppose a patient in your clinic and you start some medicine and you want to take after 1 week how much that medicine affect in your patient. That time we again measure the same thing, which was suppose any markers that was around 100 this time. After 1 week of medication, you get 50. That means your medicine is working. That is how we check our patient status. Also help in ascertaining the time course of the disease. Yes, sometimes you have seen that a patient asked to eat this antibiotic for 5 days. And if that is not cured, doctor add 2 days more, or sometimes go for 2 weeks or 3 weeks, depends on the severity. That means course of disease, to identify the course of disease also help by these biochemical markers, particularly in the enzyme, particularly by the enzymes. Yes, enzymes is a diagnostic marker in different diseases. These are the most common diseases. There are more and more diseases, but we are just talking about very common diseases, which are very common in our society as well as the community. Enzymes estimation are helpful in the diagnosis of myocardial infarction. See, this is the one biggest global threat, and annually nearly 18 million people are dying with this cardiovascular disease. And the number one of this cardiovascular disease is myocardial infarction, that is very well known as heart attack. Yes, and even coronavirus, if you see the latest topic, however, that is related to microbiology, but this just going on topic, that's why I'm focusing on corona only. And many patients are dying with myocardial infection having coronavirus infection. That means myocardial infection is very common. And previously it was thought that this disease is for rich people or obese people or something like that, but no, nowadays this myocardial infection is very common in low-income countries like Nepal, India, and Bangladesh, Bhutan, these low-income or developing countries has a very high prevalence of this myocardial infarction. So we can identify with the help of some biochemical markers whether this person is suffering from myocardial infarction or not. Liver disease, there are many types of liver disease. Like cirrhosis is a very severe condition, jaundice another liver disease, hepatitis, many diseases are there. Just in basket we are saying liver disease, muscle disease, many muscle diseases are there, like muscular dystrophy is a very one genetic disease where muscle get damaged, and ultimately person die within 12 or 14 years of age. That is genetic disease. Bone disease, yes, there are many bone disease, decay of bone, like rickets and something like that. There are many bone disease. Cancers, this is very well known word by all, anyone know cancer nowadays. GI tract disease, many cancers related to GI or ulcer, many diseases again related to GI tract. These are the very big picture only. I'm not going to talk individual disease in this slide because it's just about the particular organ or system related to disease. And we can identify with the help of some biochemical markers which disease, where is the disease, how severe is the disease. We can identify, we can differentiate, we can manage with the help of these biochemical markers. That's very important. Yes, diagnosis of AMI, that is acute myocardial infarction. Let's start from the acute myocardial infarction because it's very common in the global. The diagnosis of acute myocardial infarction usually predicted on the World Health Organization criteria of chest pain. This is the frank history of patient. If a person having myocardial infarction, the frank history, he or she will say, I have a chest pain and in the left shoulder, and that radiate to the arm slowly, and there is a change in the ECG, especially PQRS, that the ST segment is elevated when we go for ECG, and increase in the biochemical markers of myocardial injury. That means our focus is in biochemical markers. We don't know about chest pain, we don't know about ECG because we are in the biochemistry only now, and when the patient sample come to the biochemistry laboratory, that time we ask for history or whatever, what is the ECG, what is the patient history, but we are focusing only in the biochemical marker of this myocardial injury. Half of the patient with typical symptoms do not have AMI. See, if only symptoms can predict AMI, why we need any markers? That is the question. That the answer is here, half of the patient with typical symptoms do not have AMI. That means only symptoms are not sufficient to diagnose. If that is okay, only symptoms can reflect the actual image of the disease, why we go for the another test? But it's saying that 50% of the patient have symptoms of AMI, but they don't have actually AMI, because AMI have a very similar picture with gastritis sometimes. That's why it's very difficult. And the ECG is specific for AMI but lacks sensitivity. See, yes, ECG is very easy to do, and it's specific for this cardiac muscle, but it lacks sensitivity. That means it's not very sensitive. Yes, it's specific because ECG for electrocardiogram, that means for the cardiac muscle only. That's why it's specific. But the sensitivity is very low. That means it's not very sensitive. It's difficult even to read. In contrast, biochemical markers have excellent sensitivity for diagnosis of AMI. See, we have ECG, but ECG is specific, but it is not sensitive. So biochemical markers have excellent sensitivity, but they are not very specific sometimes. There are some markers we are very specific also, but many markers are not very specific. That time we do one is specific and other sensitive, and read both markers results together, and then we get the best picture of that patient. By combining the most sensitive and the most specific test, diagnostic accuracy can be enhanced. Yes, we have one very sensitive method, we have one specific method. Then we do both and then read the result of both tests, then we can have a very accurate diagnosis of the that particular patient. This is how we do. And the serum enzymes in acute myocardial infarction, there are few enzymes we measure for these patients who have a frank history of myocardial infarction or heart attack. Creatine phosphokinase, generally phosphokinase, creatine phosphokinase, as we discussed in creatine synthesis, that is one enzyme having three isoenzymes, CKMB, CKBB, CKMM, but we will discuss CKMB more. However, we know about CK also, CK total, that means aspartate transaminase and the lactate dehydrogenase. These are the enzymes. Generally, they obtained a very high level when the person suffering from myocardial infarction. Acceptable biochemical markers of ischemic heart disease are now considered to include myoglobin, another one, CKMB, total CK, that is CK creatine phosphokinase, cardiac troponin, T and I. That means these are the enzymes or proteins which can be measured to rule out a person suffering from myocardial infarction or not. We, along with ECG, without ECG it's not very easy sometimes. So we can measure myoglobin, a type of hemoglobin, myoglobin, a type similar to hemoglobin, not exactly. It is protein. CKMB, that is isoenzyme of CK, total CK, and cardiac troponin T and I. There are T and I, three types of troponin. We generally measure T and I. We see it here is a one heart. There is a this coronary artery is blocked, and that block causes damage, in particular this cardiac tissue. And when there is a damage, these enzymes release into the blood, and we measure that. As we say, there is some reason why this is high, because that tissue or cells are damaged, and ultimately, you see here is a block due to this plaque formation of this cholesterol, and that's why blood cannot flow. And that time, when there is an obstruction, there is a risk of or chances of damage of this tissue, and that tissue damage, they release these enzymes and protein into the blood, and we measure in the blood, and we obtain very high that confirms the patient have some degree of myocardial infarction. Let's start from creatine kinase. Creatine kinase, either CK or CPK, these both abbreviations are used simultaneously. CK or CPK both same. It is an enzyme found primarily in the heart and skeletal muscle. We know very well this enzyme because we have already discussed how creatine is synthesized in our body, and that is the enzyme which is responsible for the synthesis of creatine, skeletal muscle, and to lesser extent in brain, but not found in liver and kidney. Yes, very low, not found means in brain, in the kidney, very, very low, or you can say it's not found actually. Catalyze the transfer of phosphate between creatine and ATP. Yes, we already know that creatine phosphate, we have just creatine, we add phosphate molecule in the creatine to produce creatine phosphate in the presence of enzyme, this creatine phosphokinase, we know that already. And provides a rapid regeneration of ATP when ATP is low. That means if we have a creatine phosphate, that time in the presence of creatine phosphokinase enzyme, we easily produce one ATP by just combining with adenosine diphosphate molecule for instant source of energy. Creatine phosphate is regenerated when ATP is abundant. That means this creatine phosphate molecule again regenerates when we have a sufficient amount of ATP. This is how we already learned in the creatine synthesis. And creatine kinase, after myocardial infarction, serum value is found to increase within 3 to 6 hours. Remember this line. Once a person having myocardial infarction, this creatine phosphokinase enzyme increase within 3 to 6 hours. It means, suppose one patient come to your clinic and having chest pain of history of half hour or half an hour or just 1 hour. If at that time you draw blood and send to the biochemistry laboratory will give you very, very normal report. And that time you will think, oh, this laboratory is worst. They are a patient having very frank history of myocardial infarction, and the ECG has a very good high value of this ST segment, but biochemistry report is not good. That means not biochemistry. There is no problem in the biochemistry. Actually, the problem is the history of patient, or the actual blood should be drawn after 3 or 4 hours only. Then only biochemical markers will be high. That's why you have to think about history details and the mechanism behind these all enzymes and protein. Otherwise, it's a waste of time and waste of money. Reaches a peak level in 24 to 30 hours. See, very, very high amount is produced in 24 to 30 hours and return to the normal level 2 to 4 days, usually in 72 hours. That means, suppose a patient have a history of chest pain 12 or 20 hours ago, and now he is in your clinic because he lives or she lives in a very far away from your hospital or clinic. That time even you can measure these, and you will find definitely very high value of this creatine phosphokinase enzyme if that person have a myocardial infarction. Creatine kinase is a sensitive indicator in the early stage of myocardial ischemia. See, creatine kinase is a very, very sensitive marker in early stage of myocardial ischemia. No increased activity is found in heart failure and coronary insufficiency. That means sometimes patients are not giving exact history due to lack of some knowledge or something like that, or we have some mix of knowledge, or we are even not very clear about that. That time some people believe that, no, not believe actually, some people don't know heart failure and heart attack both are different. Remember this line, heart attack and heart failure are not same, they are totally different. Heart attack, it's a very acute condition. Heart failure is a chronic condition. Heart failure doesn't happen within few seconds. It has some previous exposure or abnormality with heart failure, because heart failure means the heart is unable to pump the blood due to weakness of cardiac muscle. But heart attack is there is a blockade of this coronary artery. That's why we have to very clear picture and knowledge about what is heart attack, what is heart failure. Then only we have to request test accordingly. In acute myocardial infarction, CPK usually rise faster than SGOT, serum glutamate oxalate transaminase. This is another enzyme transaminase we measure generally in, to rule out myocardial infarction. But see, creatine phosphokinase, it usually rise faster than SGOT. That means that SGOT also increase in myocardial infarction. CPK also increase in myocardial infarction. That time you have to focus more in the CPK rather than SGOT, because it will increase, because CPK increase faster than SGOT and returns to normal faster than SGOT as well. That's why this is more sensitive than SGOT. Now we will discuss more specific isoenzyme about myocardial infarction. There are 3 isoenzymes of this creatine phosphokinase. Measuring them of the value is the presence of elevated level of creatine kinase or creatine phosphokinase. To determine the source of the elevation, we have to find out what are the possible reasons to provide this high value of creatine phosphokinase. If we measure total creatine phosphokinase, that time it's very, very difficult to differentiate which muscle is damaged actually, because we know creatine phosphokinase has 3 isoenzymes: CKMB, CKBB, CKMM. BB for brain, MM for muscle, CKMB for cardiac muscle. That time, if you measure CPK or CK only, it is very high. Then how you differentiate it? That person has a myocardial infarction, or maybe injury in other muscles, or injury in brain. It's difficult sometimes. That's where we have to go more specific isoenzyme. Each isoenzyme is dimer composed of 2 promoters of M for muscle and B for brain. These enzymes can be separated by electrophoresis or by ion exchange chromatography in the laboratory. We can differentiate these by electrophoresis or by ion exchange chromatography. We will see this device and we will do electrophoresis in our laboratory once this corona allow us to enter in our laboratory. We will do how electrophoresis is done. And see, if we check for this, CKMM, electrophoresis mobility is very low. It is present in skeletal muscle and heart muscle. Mean percentage in the blood is nearly 99%. That means the highest amount of this CK3 is in our blood. CKMB, this is intermediate in electrophoresis. Heart muscle 1 to 3% in. This is the amount of this. Suppose you have CK total, then out of that total, nearly 99% is this, 1% this, and 0.021% is this BB. That means CK high, CPK total is very, very high in this. And any one of these, either heart muscle or brain or skeletal damage, it will be high again. But here we are saying the amount of percentage. Suppose we measure these all three and this we get 25%. That means there is a problem in the cardiac muscle. That is how we diagnose the cardiac tissue damage or myocardial infarction. Normal level of the CPK are almost entirely from skeletal muscle. The normal level of are almost entirely. That means generally this is very, very within normal range. Elevated level of these resulting from acute myocardial are about half mm and half mb. That means if we found elevated level, there is chance of either from brain or from cardiac muscle. But mostly they are chances if patient has a very frank history of chest pain, hypertension, smoking history, difficulty in breathing. That time if you measure CKMB as well as you have ECG, it's very, very easy to differentiate. That's why we do more and more diagnostic tests. Myocardial muscle is the only tissue that contains more than 5% of total CK activity as CK2MB isoenzymes, especially when we have a muscle tissue damage. That time we may get more than 5% of CKMB in our total CK. That means it's generally 1 to 3%, but when there is a muscle damage, we may get more than 5% of CKMB in our enzyme diagnosis. Following an attack of acute myocardial infarction, this isoenzyme appear within 4 hours. Yes, I told you 3 to 6 hours. Following one set of chest pain reaches a peak of activity approximately 24 hours and fall rapidly. That means it start increasing in blood after 4 hours and the peak is 20 to 24 hours, then it drop down again. CKMB accounts for 4.5 to 20% of the total CK activity in the plasma of the patient with recent myocardial infarction. See, normally this CKMB is 1 to 3% of total CK, but it can be 4.5 or 5 to 20% of the total CK activity in the plasma of the patient having recent myocardial infarction. And the total CKMB is below 25 units per liter in normal condition, but it may be up to 200 or 250 or even 500 you can get, because up to 20 folds it may be high in myocardial infarction. Yes, the next, after that, once we have a very brief idea about the CK, why we measure that, when we measure that, now I think you are able to find out if a patient have some history of myocardial infarction, you have to measure CKMB. There are other, you can measure CPK total also, but you have, if available, you have to measure CKMB because that is more specific and sensitive along with ECG. Not only that, troponin I is more sensitive than CKMB, but we are talking about enzyme here. Troponin is just a protein, not enzyme. That's why we will discuss troponin in the end of this. And the next enzyme, which is increased in myocardial infarction, that is aspartate aminotransferase, AST, or SGOT, also known as serum glutamate oxaloacetate transaminase. These enzymes are present in liver also. That's why sometimes it's very difficult whether there is a problem in the liver or in the heart. That's why we said these are less sensitive or less specific. It is also called serum glutamate oxaloacetate transaminase, SGOT, or simply AST, aspartate aminotransferase. The level is significantly elevated in acute myocardial infarction. Generally, we have 5 to 40 international unit in our blood per liter. In acute myocardial infarction, serum activity rises sharply within the first 12 hours with a peak level at 24 hours over and return to normal within 3 to 5 days. See, the problem is here, 12 hours. That means suppose a patient come to your clinic having frank chest pain with difficulty in breathing and other symptoms related to the myocardial infarction. But you know that SGOT will increase after 12 hours. Then what you will do? Will you say to hold on, once you will have 12 hours, then we will do test? No, that is nearly crime and patient will die. That's why we don't wait for this test. We just go for CKMB because that is start increasing 3 to 6 hours. That is better than this. But nowadays, especially in private hospitals where they have to manage entire hospital and the staffs, everything, and they have to take some benefit also because they have invested millions of rupees in that private sector or corporate hospital. They do all tests to earn money as well because they have to earn because they are paying very huge amount of medical doctors, nurse, laboratory staff, and overall management. That's why they do all these tests. But when you need just the test or you don't need any money, no need to do this test. But you have to idea at least because you are just a student, you should know what are the other tests we can measure. Suppose you are in a very remote area or suppose you are in a Dolakha, there is no big hospital. They can't measure creatine kinase, then that time, yes, you can go for that. This at least you have some picture of this SGOT. That means you can ask the laboratory staff, can you perform liver function testing here? Yes, they will say yes. Then you can go for SGOT and you have some idea about this. That's why you have to knowledge about these all, but these are not very good tests compared to that CKMB. But these are increased in myocardial infarction. The rise depend on the extent of infarction. Reinfarction result in secondary rise to SGOT. Sometimes a person having multiple attack. That means one heart attack comes now and after a couple of hours another attack will be there. That time SGOT will continuously increasing and increasing and increasing. That time we may confuse. No, we read in biochemistry that it fall down after 72 hours or 3 days or something like that. That time also you are getting very high. That means don't confuse yourself because maybe there is a chances of re-attack of this heart attack. Sometimes that will also happen. Multiple attack of the heart attacks. Minor, but they are multiple. And other disease, the rise in the activity is also observed in muscle and hepatic disease. Yes, I told you, the rise in the activity is also observed in muscle and hepatic disease. That means that SGOT or AST can be increased in other diseases rather than heart attack or myocardial infarction. These can be well differentiated from simultaneous estimation of other enzyme activity like SGPT, which do not show the rise in activity in acute myocardial infarction. That means sometimes if you have a confusion in the laboratory picture, that time you have to go for another test to differentiate yourself. Suppose you get very high value of SGOT. And that time you are unable to differentiate it due to some liver damage or other muscle damage or it's cardiac muscle damage. If you do SGPT also, that time you can really differentiate because if that is SGOT is high due to the liver disease, definitely SGPT also high. And if you found SGPT is normal and only SGOT is high, definitely that is related to your myocardial infarction. That is how we differentiate patients from other disease to myocardial infarction. And third one enzyme we do that is lactate dehydrogenase. Yes, this is the enzyme we read it in the Cori cycle, lactate dehydrogenase, the enzyme which can convert lactate to pyruvate in the liver, and that pyruvate ultimately converted into glucose, which we said this is gluconeogenesis, and that is an example of gluconeogenesis, and the Cori cycle is an example of gluconeogenesis. That lactate dehydrogenase we can measure in our laboratory. Catalyze the reversal conversion of pyruvate and lactate. Yes, it's normally its biological reference is 55 to 440. or simply you can remember 50 to 450. It doesn't matter if you change some 5-10 units, because it depends from where you study and what method you use. That's why it's not exactly that you have to remember like this is sharp. No, you can say 50 to 450 even, you can remember like that. The level is in upper range are generally seen in the children. Yes, even children that don't have any myocardial infarction, but they may get very high value of this lactate dehydrogenase high, because it is not very specific only cardiac muscle. It is related to lungs as well as liver as well as other bone and other tissue. That's why it is a little bit higher in children. LDH level is 100 times more inside the RBC than in plasma, and therefore minor amount of hemolysis result in false positive result. See, many times once you start your duty in clinical setup, when you are in third year or fourth year, that time you will see how many samples rejected by the biochemistry laboratory every day. You will see. And we reject sample when there is a mild hemolysis. Why? If there is hemolysis, there is a chances of false high positive result. That means because these enzymes are present in the RBC. After hemolysis means breakdown of RBC. And if due to some problem in sampling, that time if there is a hemolysis, and definitely you will get very high amount of LDH and your diagnosis will be wrong. That's why we reject the sample and we ask for please send another sample which is not hemolyzed. In acute myocardial infarction, the serum activity rise within 12 hours. Again, see, this is not very specific, sensitive and specific, because it said it start increasing within 24 hours, 12 hours. Attain is a peak in 48 hours. See, and we know that acute myocardial infarction is a emergency condition, and we cannot wait for that. Oh, wait, once you have a 12 hour, then we will measure LDH, and then we will decide. No, you can't say that, because the patient will die. That's why we have to manage in an acute response way, emergency way. That's why we have to idea. We must have some knowledge about this weight, when it increase, weight in the normal or something like reaching about more than 1,000 internal unit per liter, then it is gradually to normal 8 to 14 days. But these days are important only in such conditions. Suppose a patient come to your clinic 3 days after his chest pain, because he or she lives in very remote area, and when they get chance to come hospital, then they have history. That time there is no meaning of doing CKMB, because that will be definitely normal. Because now patient is saying, no, now I don't have any pain. But that time if you do this LDS test, still you will get very high, and you can say, yes, you definitely, or you might have a heart attack 3 days back, so that you need to investigate further other investigations like echocardiography, or sometimes these CT scan, especially to see the blockade in the coronary artery. The magnitude of rise is proportional to the extent of myocardial infarction. That means the value is directly proportional to the severity of myocardial infarction. That means how severe was the myocardial infarction, that much the muscle was damaged, and that the amount of accordingly high this LDH in our blood. Serum LDH elevation may persist for more than a week after CPK and SGOT level have returned to the normal level. See, that means CPK or SGOT are already normal, because patients come to your clinic after 3 days of attack. That time there is a waste of time and money if you do CPK or SGOT test. That time you have to test LDH, and still you can find there is elevation of LDH. Yes, you can say, yes, you had a heart attack 3 days back. Other disease also. But once you get very high value of LDH, it doesn't mean that the patient must have a heart attack. No, there are other reasons also. Other disease, these increase the serum activity of this lactate dehydrogenase, is also seen the hemolytic anemia. See, if patient has hemolytic anemia, I told you, because hemolysis can increase the LDH value. And what if the patient has already a type of anemia that is called hemolytic anemia, or like sickle cell anemia, because there is a rapid hemolysis automatically inside the body. Hepatocellular damage, Muscular dystrophy, yes, muscular dystrophy. Muscular dystrophy is a very common muscle disease. Carcinoma, leukemia, and any condition which causes necrosis of the body cells. See, these are the huge number of diseases which are related to the increased value of LDH. That means it is not very specific test, because specific means that is particularly specific for one tissue or organ. But see, we can see here hemolysis, hemolytic anemia, hepatocellular damage, muscular dystrophy, carcinoma, leukemia. All these conditions are saying that there is a chance of high LDH. That's why it's very, very difficult to differentiate with the help of this test only. Since the total LDH is increased in many diseases, so the study of isoenzyme of LDH is more significant. That means LDH, like CPK, that has 3 isoenzyme, LDH has 4 isoenzyme, and individual isoenzyme is related for individual tissue. LDH enzyme is a tetramer with 4 subunits. The subunits may be either H, heart, M, muscle, like CKMB, M for muscle and B for brain. Similarly, we have H and M, H for heart and M for muscle. These two chains are the product of 2 different genes. Although both of them have the same molecular weight, there are minor amino acid variation. There can be 5 possible combinations: H4, H3, M1, S2, M2, H1, M3, and M4. These are 5 different types of isoenzymes in this LDH enzyme. That means it has a different isoenzyme like CK total. C. These are the isoenzymes. These are 5 types of isoenzymes: LDH1, LDH2, LDH3, LDH4, LDH5. And LDH4, that means a heart unit, H unit are 4 there. LDH2 means 3 heart and 1 M. This is how we divide it in different H subunit, M subunit, like this. One is completely M, one is completely H. Here 2H, 3M, and here 3H, 2M, like this. This is how they further divided or isoenzymes like CKMB, BB, MM. Here LDH has 5 isoenzymes similarly. And these 5 isoenzymes are specific for different tissues. See, LDH1, subunit makeup of isoenzyme H4. If we do electrophoresis, it runs very fast. Not destroyed even by 60 degree for 30 minutes. Enzymes are generally destroyed after 40 or 50 degree. This is little bit temperature tolerating enzymes. And tissue origin is heart muscle. Percentage in human serum mean nearly 30%. Similarly, as LDH2, that is also faster, available in the RBC around 35%. LDH3 in the brain 20%, LDH4 in the liver 10%, LDH5 skeletal muscle. That means if we do just the LDH test, we don't know where is the problem actually. In the heart muscle or RBC or brain or liver or skeletal muscle, we don't know. That's why we are saying if you want to see what is the exact problem, you have to go for isoenzyme. Suppose you want to see whether there is a problem in the heart muscle or not, then you have to go for LDH1. But these isoenzymes are not easily available because nowadays to differentiate myocardial infarction, we have very, very good markers like troponin and CKMB. That's why we are not going for this. But we can do this for research and for other purpose. Yes, cardiac troponin is another marker. I think we will continue in next class, because if we discuss all these markers in one day, it will be definitely boring. And yes, I should say we will learn troponin in the next class. And if anyone have any question, please ask. We have a 4 minute more. Anyone ask anything? के छ सोध्नु पर्ने?
No, sir.
ल ठिक छ। अस्ति एउटा कसले हो सन्देशले कि कसले क्वेसन सोधेको थियो, सन्देश अहिले हुनुहुन्छ अनलाइन? अस्ति मलाई एउटा मेल पठाएको थियो नि, सन्देशले हो? सन्देश कि के थियो नाम बिर्से, सन्देश कसले पठाएको थियो अस्ति क्वेसन याद छ मलाई? अनि मैले एउटा भिडियो लिंक पठाएको थिएँ, बुझ्यो कि बुझेन, बुझेन भने फेरि सोध्दा हुन्छ है, म फेरि त्यसको आन्सर भरौँला, बुझ्यो भने त ठिकै छ। ल आजलाई हामी यति नै डिस्कस गर्छौँ। नेक्स्ट टाइम वी विल कन्टिन्यू अदर मार्कर्स दिस कार्डियक टिस्यु ड्यामेज, त्यसपछि हामी अरू अर्गनहरूको ड्यामेज पनि डिस्कस गर्छौँ। आजलाई हामी यति नै, केही छ भने डिस्कस गरौँ, हैन भने हामी छुट्टिन्छौँ। अब नाइस डे।
यो स्लाइड पनि पठाइदिन्छु, यो स्लाइड पनि पठाइ
ए यो पठाइदेऊ कि अथवा सबै कम्प्लिट भएपछि पठाए?
ए अहिले कम्प्लिट भएको छैन सर?
छैन, यो कम्प्लिट भएको छैन, किनभने यसमा अझै आधी मात्रै भएको छ। हाम्रो 45 46 स्लाइड छन्, आज हामीले 27 26 मात्रै सकायौँ।
हस् सर, हस्, त्यो सकाएर
त्यो सकिएपछि गरौँला है त।
हस् सर, थ्याङ्क यू सर।
ल ल ल।